Good afternoon. Good afternoon, dear colleagues. I'm Bol'shakov, software engineer of YADRO company. I would like to tell you about continuous testing. It's ACI-friendly testing of kernel code. It's a continuous integration system, and for the software engineer, it's also very friendly. In YADRO company, we create servers on the basis of open power. It's the system of data storage on open power. We've got several modules of the kernel which are integrated with the subsystem Linux, block O and target core module, and also we have our own proprietary counterplay. In order to be sure about the quality of the product, we have the storage, open up storage for all the sets of tests, starting from systemic tests to unit tests. We have got matrix builders, so we can use x86 for 64 and Power PC as well. Just is the master branch. They go through it until they become green, and then the manual testing is present as the additional one. We've got lots of different tools, but we don't want to have a zoo. We use each one of those instruments at the maximum. So, and we have got well-developed system of testing, automated testing, systemic testing, and we test control parse components. We test them as well. But how can we test them? How can we integrate them in CI? Some of those control parse components. Some might say that we don't need that. Software developer will test everything. Oftentimes we know the result. Nobody will know when something is bugged or broken. And how the software engineer, the developer, does this testing. We can see what can be done in order to figure out the way the kernel code or subsystem, a module of the kernel is tested. We can look at those testing suites. These are most famous. Linux text project is testing user space interface. Each syscall really is doing whatever it's necessary. There is no regression. User space programs are not broken. Block test is block subsystem access tests. SF could be in the bracket. It's test filing systems, or we could search for target test, whereby Linux is present as the initiator, and LNST the tests for the network subsystem. Each one of those tests has got the instruction how to launch them, how to do those tests. Here you can see those test suites, how they can typically run. But there is no mention as where to launch them, how to integrate CI. There are no instructions about integrating CI. Neither test suite has it. Just up and launch it. You won't be able to do that. You need extra information. Well, let's try to launch it locally without CI. Typically, you have some text editor present, some softwares are launched, and if you are trying to download from module drive from the same system where you work, that will bring about very sad results. You can use special dev machine and download there, but the result will be the same. It will be a bad result. You can launch at the dedicated hardware, and in our case, running the tests on dedicated hardware are awfully expensive because we make server platform. Each one of server platforms is awfully expensive, huge amounts of money vis-a-vis embedded devices. In the world of embedded devices, it's a very popular scheme. I don't have anything against it, but each board is much much cheaper there. For those who are interested in test beds, I would like to mention Automated Testing Summit. This Automated Testing Summit was in Edinburgh last week. Developers from different teams and projects were getting together discussing how they test in order to establish the common terminology, to find common ground, and somehow to start working together by joint efforts on this project problem. There are about 20 different tools resolving this task. So, as we as developers of the systems of data storage are interested in higher level subsystems and those who work directly with the hardware, we are able to launch tests in virtual machine, and this enables us to test the most part of the data path components. We use Virtu as the device. And in this scheme, there is one question: how to create artifacts and how to compile it if the kernel crashes, how to interact with virtual machine, how to get the feedback. Everybody knows about this kernel. There is such a virtual device on EP so that it will be possible to use the root system from host to guest, and we'll shift it, and router fast should not be compiled, and all those tools work very fast, and they have got interactive mode, so you're feeling it as like from Docker run, but they as they can do the shifts in the kernel file systems as to the ability to isolate the environment. It's not possible. Maybe even if we create the standalone router face ENG, but then interactivity and easiness of launching will be totally lost. How to use CI is not quite clear. They all interact with local hypervisor, and they launch the Quima, and there is the requirement that by all means there should be a host SCSI. And when we want to do something more sophisticated and complex, it's about launching of CAM until the certain mind there is the command, and then there are different options of the kernel and different components of this device. But actually, it's possible to shift this logic to fiber channel data. There is another tool. It's relatively new. It consists of 3 types of scripts. Script for connecting the usage, script to set the network, and script to launch what you compiled. So as an interface, so they use the kernel image, and the code modules of the kernel are getting there, and there could be scripts, file and module list, and there could be user space dependencies which are necessary for the test. They're also there, and it's not so easy to launch it by one team. We should think about the order. It should be done in the right order, and how to run those tests on local VM with rapid do it. But at least the repository is very interesting. It contains the templates of those scripts for some ready-made subsystems for subsystem files, but you cannot integrate it with your own module. And there are lots of big mature frameworks used in testing by large companies like IBM. Many things are very good with that, and actually their library on Python, which enables us to work with tested system to get the feedback from this tested system to deploy remotely onto hardware, to Docker, to virtual space, lots of different capabilities and features. But talking about virtual machines, they should be created before. They should be ready by that time. And now we are arriving at a situation when in each of those tools there are some absent features, which would mean that the system is convenient. Something is missing. In the first three tools, we cannot compile dumps if they just evolve. It's not possible to use this remote machine to launch anything apart from auto test. And only Autotest has got the ability to integrate, and all the others they are there. But Autotest is rather sophisticated and not so easy to launch in Autotest. If we try to combine the best capabilities of all the tools and remove the disadvantages of that, we'll articulate the requirements for K-test we made. Those are the main K-test features and goals. There are 3 shell scripts, no more than 1,000 lines altogether. It could work locally or remotely with hypervisor. It doesn't depend on the environment in which it's run, and it can just establish tools and user space. It could be tested out of a container, out of jar, and there is Docker Run interactive regime. Virtual machines are created on the request and can be deleted in any moment of time. It costs nothing. It's very cheap as a transaction. Initially, it was possible to use the module, and the way of integrating with Jenkins was also embedded initially. But as typical hypervisors are very powerful service, we would like to use a lot of different testing instances in one and the same hypervisor. Test can work in this schema. In order to have both local and remote operation by hypervisors, we didn't want to reinvent the wheel. libvirt can do everything to configure the network. It consists of 2 parts. It can manage local or remote virtualization because there are 2 parts. It's client's part, or if you would like to have the software, you can use libvirt API on Python or on other ones. There is the server. Server is libvirt TDD, which unfolds the virtual machines. And it works with the virtual machines. That can stop them, interrupt them, sending out commands to virtual machines. libvirts are supported by Linux and Mac OS in the last version of libvirt. On Linux, it's hardware acceleration using KVM, and I send the patch site to use hypervisor framework. But we should work on this hypervisor framework in order to do the acceleration. But actually it could work on Mac, and we posted this patch set actually. How does this scheme look like when we use remote virtual machine? When we run the test on a remote virtual machine, we create the description of this machine in XML file, and we run it via Virsh. libvirt has got such a feature, so it can use, apart from KVM, it can use evaluation. It's TCG accelerator, which enables us to test on the platforms, on other platforms, which are different from the one you work on. Or, in case of Mac, let's say the current state of accelerator is not always stable. As yet, it's experimental version, so you can run the kernel with tests on Mac. It will take longer, but it will be run. It will work. As to the local launch from my laptop, for example, it's possible in the following way. We turn to the local libvirt TD. All the other components are the same. And the overall process of using this test could be split into two phases which are quite transparent. It's the setting up of virtual machine. First of all, it's set up, then we're creating from test, whereas of portal for the channel of the feedback. We should launch it, funnel test results, and inside this VM system test is developed, and through virtual channel we do the power of kernel, we set up the kernel, we run the test, if everything's okay, we take away to mask or some logics which the test suite would like to store, or which are interesting for Jenkins or if in the integration system. So we'll retain it when we just stored everything. We destroy the virtual machine. If something goes wrong, the kernel is crashed, then we download the load for the kernel for condemned, and since that moment, in the memory, it is reserved. So it's the backup kernel. So and we'll reserve TCP port for to Christie channel, defined domain. Everything will be stored on the disk inside the test is done. So there is no RAMFS and kernel, and we might set up panic kernel. It will place the crashed kernel into the network, and the customer, which in the tail is testing that, he'll get this crash dump. Apart from this crash dump, there are kernel messages there as well. And if the tests are stuck, virtual machine will be sent NMI, and if it doesn't complete after that, it will be just destroyed. Actually, how do we build in KTask? How do we build in NetRAMFS? We use two kernels, panic kernel and the conventional kernel. Panic kernel and NetRAMFS. For panic, they are located in the main NetRAMFS. Apart from the kernel, apart from panic kernel, in the InfraMFS, user spaces will get which one, those who you would like to have in tests, maybe external test suites, which I mentioned before, or it could be some files which you would like to shift to other place, and for that, it's possible to create disks which will create a directory. It will make the snapshot of directory and shift its current state into virtual machine. For those tests, scratch disks could be used. They could be used for the data. In KTest, we envisage the option when virtual block and virtual course disks are created. When the virtual machine is completed,
then it transfers everything through virtual serial device, virtual channel. Virtual channel is a high-speed device, I/O device. There could be many of those, and this is how CopyPaste works also in ad-hoc virtualization. And this is one of the fastest methods to interact with virtual machine, and this is how this works. When we launch, KTest finds the port, and virtual machine becomes available through TCP port on the side of the virtual machine. It interacts with virtual channel and preserves the results which were generated after the start of the test, and sends that all to the channel. In order to use KTest with Jenkins, you need to prepare the kernel modules in order to make NitramFS. In NitramFS, you can add KTest as a submodule or just copy a Jenkins file. You will call from that file a command. KTest doesn't levy any limitations on that. In NitramFS and virtual machine is the only things that it creates. If you don't want to have in the build file a longer command for assembly, you could create file that called test, and that file would contain all options that necessary for virtual machine. And the remote start, we select token mesh, and then the image, kernel image. This is how a file could look, configuration file of KTest. We have an entry point. Then we do snapshots of directories. We create scratch disk for 10 megabyte. That is virtual block disk from virtual machine. It can be easily found by a serial number. That is equal to the name of the disk, and in NitramFS we want to have target core module. This is target of the system. We want to have a back module, and the results we want to place in the test results directory. As a result, we get the following working integration. We have matrix built, we have tests that are launched everywhere, and we have achieved the possibility to integrate with Jenkins, and also show you local operation of KTest, local work when you develop something. We remove the current results of the assembly, and then we try to make new one and test. That all was done on Mac. First launch contains also creation of generation of NitramFS. This is one of the longest parts operations, but KTest monitors that files are not changed or replaced, and that allows to avoid creating it again. Now that it's launched already, tests have run. 6 seconds, you see, for all cycle of work of virtual machine. If we don't do tests, then it's only 4 seconds, it's close to limit. And now we can look at the login of the core kernel. We got some SCSI disk as a result. It was read. There is no partitioning on that. That's why you don't see it. Now we try to work interactively. There is a shell. Now the setup tests were launched, and now we can investigate the file system or do anything else we want with that, depending on what we want. ID disk we can look up, for example, that now is become available. Became available, and we can verify that the disk has correct identifiers, can correctly react to commands. This is stopping of the machine. It's quite fast. And now scenario when everything goes awry, not correct. I didn't add code here that would provide the 0 parameters. It just called up crash trigger instead of a test. This is a test. We call crash. Now the crash happens and the kernel is loaded. Storage of image has happened, a memory image that we can investigate later if we like. This is a dump archived. There is also kernel ring buffer. And this kernel IPSA moment you can also see. So this is a repository of materials. What else I can add? It would be nice to be able to launch cluster in the virtual machine, that the virtual machines would integrate it somehow in between and interact. That would be useful for cluster scenarios. Such possibility is available in some scripts in the Ceph team, the cluster storage that they developed. Block device cluster storage, and it would be nice to have this here, so that if the kernel is frozen or something, we can send it to it in NMI. VFIO PCI would be great to have for pass through. That of course limits migration possibilities of launching of KTest at various servers, various hypervisors, but for certain situations it will be useful to have, and also possibility to install various binaries would be great to have. Tools I would like to mention too. Tools that made me think about this KTest, the writing of KTest, and one of them I mentioned already, WordMe, and this is the talk of Stefan Hainocci that you see also at the bottom about the kernel development. Thank you. Any questions?
Как у нас дела с вопросами?
All right, who has questions, please? Good day, I have this question. Maybe it was not your task, but what about integration to other systems, KTest integration, Billboard, for example? It's shell script, you can integrate it with anything. There is no Jenkins link or limit. And also a question, maybe not directly to the topic, but just curious. Is the KTest or something else instead that if the kernel is compiled with flags, like tracing, that it allows repass to the host of the developer so that the developer could look it up in the kernel shell. Maybe there's something else for that purpose. You can do through virtual channel from the kernel. You can develop your own device, of course, but virtual channel is a symbol channel. You could write anything into it, and on the other side of the channel, somebody could review that. So it's two-way. And one more thing, in your presentation, you mentioned that if we do our own modules, to compile that in the kernel, that could create problems. But I probably missed why, what could cause such own. Or maybe in some other systems, K-test, that was the result. It's before you started to speak about K-test. You mentioned that with your own modules there could be problems. If it's not a K-test, but something else used. I am not sure, and I remember. I don't know what to answer actually. The K-test, the purpose of that is to launch a kernel with certain modules, and there are systems that take already something assembled, something ready, and test it. Kernel CI, for example, it's a quite well-known project, but the feedback cycle is 6 hours. It is a long time assembling, and then 6 hours for developer is not convenient to wait that much. And I'm not sure that you can send or request a job. This is a module of my kernel, please test it, or my core, and that is there, but it's not conveniently arranged, and also from point of view of feedback, it's not convenient. It could be for a team of developers if they know already configuration of the core, they don't do anything custom, they could use that, right? Okay. Okay, next question, please. I have seen here somebody who wanted to ask a question. Good day. You were speaking about a cycle that in the beginning of the initialization of virtual machine and then ending with the results. And if there is a loop, then virtual machine is killed, and this is the end of it. Two questions. How you know that the virtual machine is frozen, how you see that, and second, what you do to find out why. Because if you just remove virtual machine, you would not find out what was the reason for freezing. Thank you for your question. Stop of a virtual machine work happens in two stages. Timeout that you can define. Anonymized signal is sent. It's unmasked interruption signal that makes virtual machine to crash. As I demonstrated in demo, that will be crashed and will try to store a panic kernel, panic initramfs, try to store the image of the core in the memory which existed at the moment of the crash. Only if that doesn't find enough time to. So after that, there is an attempt at least to do that storage before it crashes actually, but it doesn't help with hard and soft lookup as we would like, because we need to have the ad-hoc device. And this is the thing that kills the system if it's not specified. The ad-hoc, you said that you plan to introduce that, to include it. Yeah, that would be great to have. Thank you.
What else? Two more questions. One more question.
You should.
Przepraszam.
Good day, thank you for your presentation. Winsoft, you spoke about hard and soft problems, lookup. As far as I know, in the core there is a mechanism of debugging that allows to retrieve diagnostic information in case of that happening. Why you need a timer if there is a debugging of the core provides this information? Yeah, that soft you can remove here. That you're correct. We don't need it here. When you have user space and some time for execution, the only thing, maybe you don't use debugging core, but some other. Yeah, that is true. We test using stock core, not debugging core. So at least it makes sense to check on both, because debugging core could show you mistakes, which also think about one more core to test it on in the near future.
Как у нас еще вопросы?
What about other questions? No more?
Тогда докладчик выбирает, кому
the
из
speaker
задававших вопросы.
Is asked to choose the most interesting question for the prize.
Отлично.
Hard soft lookup. Okay, that
Ну и
is a t-shirt, prize, and
и кофе.
coffee pack of coffee from organizers.
Спасибо еще раз
Thank you
докладчику.
once again to speaker.